To talk about relative extrema today. There's three types of relative extrema. Here we're at the bottom of a surface, that's a relative minimum. Here we're at the top of a surface, that's a relative maximum. And here there's a saddle point. If you're looking at it this way, we're at the top of a hill. This way we're at the bottom of a hill. It defines a saddle point. Kind of looks like a max, min, depending on which direction you look at it. In each of these cases, we have two horizontal tangents, one in the x direction, one in the y direction. And that's how we find critical points. Here we have something called a second partials test. We'll work through this. This is for determining whether or not we have a saddle, a relative minimum, or a relative maximum. So we have a very simple problem, f of xy equals x squared plus 2x plus y squared. This is actually an elliptic paraboloid shifted. This 2x term shifts it. So it's an elliptic paraboloid. It's going to look like this if you were to graph it. So first of all, we're going to find the critical points. We find the x partial and get 2x plus 2, set it equal to 0, and that gives us x equals negative 1. And then the y partial, fy, is 2y, set it equal to 0. We get y equals 0. So we have one critical point, negative 1, 0. Now you can substitute in here. I'll just say f of negative 1, 0, whatever it is. It's not that difficult, but if you're working a problem out in its complicated expression, feel free to just write that. We can always do the simple computation. Now the question is, what is it? Well, we need to calculate d. Second x partial, so here's the first x partial. The second x partial is 2. And then the second y partial, which is partial of 2y, is also 2. And then fxy squared, that's a mixed partial. Well, let's see, we take the x partial, a y partial of that, those are all constants. So we get 0 squared equals 4. And we'll notice that's greater than 0. So it's actually either case 2 or case 3. Okay, we're right here. So now we need to go look at the second partial. I guess I should mention, we want to find d of negative 1, 0, which is also equal to 4, which is greater than 0. Sometimes if this is a higher degree function, then we have to actually plug in the point. So now f x of negative 1, 0, we calculated that already. That's equal to 2, which is greater than 0. And let's see, we are, this case right here, the second partial of x is greater than 0, so it looks like we have a relative min. Negative 1, 0 is a relative minimum as we expected. You can actually complete the square with this, and this is x plus 1 squared plus y squared minus 1, and you can see where the negative 1, 0 comes from. That's right at the turning point. So we'll be back with another example. It's a little more complicated. Meantime, my cat's restless. And how about if Sunshine says hello? Okay, we'll be back shortly.